Good morning and welcome to the video for Friday, January the 8th. This is going to be a video for 5th grade covering lesson 6.3 in Go Math. Today we are working with estimating, 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 estimating. I'm going to say it a bunch more times because we don't need to find exact answers today, okay? So this should be a relatively easy lesson for us. We are going to use our benchmark fractions to figure out if we're closer to 0, closer to 1/2, or closer to a whole. Okay. In some cases, we might do like 1/4, 2/4, 3/4, but most of the time we're looking at comparing to 1/2, closer to 0, or closer to 1. Okay. So we're not going to be doing any weird things with finding equivalent fractions so that we can add or subtract. We will do that at another time. Okay, so we don't need to worry about that part today. So let's look at our unlock the problem. We are going to start by saying Kimberly will be riding her bike to school this year. The distance from her house to the end of the street is 1/6 of a mile. And the distance from the end of the street to the school is about 3/8 of a mile. How far does Kimberly travel to get to school? So we can go ahead and say estimate both of these. So they want us to put 1/6 on the number line. Actually, I will go ahead and use red. So I'm going to put a red dot here. You go ahead and do that. I will talk about these questions in just a moment. I'm going to do the first couple parts where we go ahead and figure out where these go. Next thing we're going to do is go ahead and put this here. And so now let's go ahead and round these. So as we're looking at these, we can go ahead and say that this one is closer to 0 than 1/2, right? We've got a few more parts that we need to add to get up to 1/2, and we're only one part away from essentially nothing being there. If we compare this one, we're only one part away from 1/2, so we're really close to 1/2 and a lot farther away from 0. So this fraction for the first one is going to be, between 0 and 1/2. And we are closer to 0. So for this one, we're going to round to 0, and we're allowed to do that. Now, I'm telling you to round with whole numbers. Sometimes we want to make sure that we don't round to 0 if we're working with hundreds. So let's say we're rounding things to the nearest hundred, and we want to do like 150 plus 40. We could go ahead and round up, and like we would get 200 plus, and then we would round down to 0, and it works out okay. There are sometimes that doesn't work. For working with fractions, it'll be okay, all right? So anytime we have the option, if we're really, really close to 0, go ahead and treat it as 0. We don't have to try to manipulate it in any way, okay? We'll still get an answer that makes sense. All right, so 3/8 is going to be between 0 and 1/2. But this time we are much closer to 1/2 than we are to 0. So we're going to round to 1/2. And then we are going to go ahead and add those together. So this one is going to be worth 0. Oops. This one is going to be worth 1/2. And then when we add those together, we would get an estimate of 1/2. And so if we go back up and look, if we wanted to find the exact answers here, we're still going to be closer to 1/2 than we are going to be to 0 or a whole. So 1/2 is a really good estimate. So when we're doing the actual addition and subtraction parts later and finding equivalent fractions, our benchmark and what we're doing with our estimates can help us figure out if our answer actually makes sense. So that's why we're doing this today. So let's do a similar problem. This one will be on the next page, but we're going to be doing subtraction this time. So we are going to try to subtract 9/10 minus 5/8 just by using benchmarks. So if we are comparing, and of course I see this thing out here, and it's got fraction of the same numerator or denominator for being a whole, and then it goes all the way out to 96 plus 96 over 96. So I've told you guys in the past that when you're doing equivalent fractions, you could get really crazy and come up with really large numbers if you want. Here's an example where they did that, but maybe we don't need to do that. So 9/10 is going to be closer to 0, 1/2, or 1. So think about that for a moment. Think about how many parts we would need to have exactly half of 10, and that can help us answer that question. So 9/10, again, if you need to pause at any point, and I haven't said to do that, you can go ahead and do that. 9/10 is going to be closest to a whole. We're going to be 4 parts away from being at a half. We're 1 part away from being at the whole. And we're 9 parts away from being at 0. So for this one, 5/8, 4/8 is exactly 1/2. So we would need a few more parts to get up to our whole. So this one should be rounding to 1/2. And then when we add those two together, we would get 1 plus 1/2, and that should give us the answer 1 1/2. I'm sorry, I'm adding. I hate when I do that. All right, so let me try that again. We are not subtracting on this one, or we're not adding on this one, we're subtracting. So 1 minus 1/2. So in this case, what we could do, and I know you guys probably don't remember this, or at least not all of you, what we would end up doing is writing this out here. We are going to trade our 1 in for 2 parts out of 2. And so we're going to do 2/2 minus 1/2, and that's kind of what they were talking about with the equivalent fraction up there, is 1/2. So that's going to give us 1/2 for our answer. Let's go on to our next page. Now we are going to estimate a couple of these. So I'm going to do one more like this, and then I'm going to have you guys try a few on your own. And I'm going to have you pause the video while you work on them. So number 1, we are working with 5/6 and 3/8. So again, think about what we just talked about. What would half of 6 be? Is the number that is our numerator, is that going to be larger than that number? If so, we're closer to 1, perhaps. And then we're going to do the same thing for 3/8. So pause the video if you need to help you figure out what our benchmark fraction should be, and then we're going to go ahead and come up with our estimate after that. All right, so assuming that you did that, 5/6, so 3 parts out of 6 is going to give us exactly 1/2. So we're 1 part closer to a whole than we are to a half. So we're going to round that up to 1. The next one, 3/8. So we're 1 part away. We need 4 parts out of 4 to be exactly at 1/2. So we're in between 0 and 1/2, but we are closer to 1/2 for that one. This time we are actually adding, not subtracting, so I will do it correctly. 1 plus 1 1/2, or excuse me, 1/2 gives us 1 1/2. Now, when we're working with mixed numbers like we have in number 3, the only part we're worried about is still the same thing. We're worried about the fraction part. Is the fraction part closer to 0, 1/2, or a whole? If it's closer to a whole, then we're actually going to round up this whole thing, and that would become 3, because we would have the 2 whole numbers that we're counting here, plus we would be rounding the fraction part up to a whole number, so that would change us from 2 to 3. If this part were closer to 1/2, then this would become 2 1/2. So just to kind of remind you how that part should look. And what I want you to do is go ahead and look at number 2, number 3, and number 4. Go ahead and pause the video if you need to, work through what your equivalent fraction should be, or sorry, again, we're not doing this. I keep saying it so I don't mess it up, and so you don't mess it up, and I'm keeping messing up. So apologies for that. We are just rounding. So find your benchmark that this is going to round to for each fraction, and then go ahead and either add or subtract. So pause the video if you need to, and when you're ready, hit play. All right. So again, I'm probably going to step over myself and keep saying the wrong thing. Hopefully I don't do that, because we are estimating. So hopefully I can remember that so I don't tell you the wrong thing. So if we were comparing 5 parts out of 9 to 0, 1/2, or 1 whole, this is going to fall between 1/2 and 1 whole. So half of 9 is actually 4 1/2. We are not allowed to do 4.5 or 4 1/2 over 9. You'll be allowed to do that when we get into 7th grade. But for today, we're just going to say that this is closer to 1/2. And because we are much farther away from 1 than we are from 1/2. And then 3/8 is going to come out being closer to 1/2. So I'm going to end up with 1/2 minus 1/2 equals 0. So I'm not going to have anything left over with my estimate. If I did the exact amounts, we probably would have something left. But again, we're not working on that today. All right, next one. 6/7 is going to be very close to a whole. Again, 3.5 parts out of 7 would give us exactly 1/2. So we're between 1/2 and a whole, but we're closer to a whole. In this case, we can go ahead and say that 2.5 parts out of 5 is going to be 1/2. So we are closer to a whole. So this is going to be 2 whole plus 1 whole that we're rounding up to give us 3. And this is going to give us a whole number for the answer. In this case, it will be 4. And then our last one, apparently I need to zoom out so I can drag my screen over here. I'm zoomed in so far because I'm having difficulty reading it. Even though you can probably see it fine when you're watching the video, assuming that you're not on a teeny tiny phone. But even then, you can probably still see it a little bit better than I can when I'm looking onto my laptop monitor here from my big TV that I use so I can actually read things. All right, so 5/6, 3 parts out of 6 gives us a half, so we're closer to a whole. In this case, again, 2.5 parts would give us exactly 1/2, so we're actually in between 0 and 1/2, but we are closer to 1/2. So 1 plus 1/2, and that's going to give us 1.5. So hopefully by this point, this is starting to make a little bit more sense. We're not doing anything too terribly crazy with this. We're going to do a few more of these practice problems. I think what I'm going to ask you to do is do number 6. I want to do one of the subtractions, but those are all the odd ones. So I want to do number 6, number 9, and we'll also do number 10. So go ahead and do those 3 problems. Let's go ahead and figure out what our benchmarks should be when we're estimating. And then we'll go ahead for number 6, we're adding the 2 benchmarks or estimates together. Number 9, we're subtracting. And number 10, we're adding again. So go ahead and pause the video while you work on that. When you're ready, go ahead and hit play. So number 6, our 1/6 side is going to be closest to 0. So it's going to be between 0 and 1/2, but I would need 3 parts out of 6 to be at 1/2. So I am actually closer to 0 here, so I'm going to rewrite that down below as my estimate. 0 plus 3/8. So again, we're between 0 and 1/2, but this time the 3/8 is actually going to be 1 part away from the half compared to 3 parts away from 0. So we're closer to 1/2. So if I go ahead and plug that in, 0 plus 1/2 is going to give me exactly 1/2 for my estimate. We would get something slightly different for the answer, but even if we decided that this was supposed to be something that's slightly larger than 0, and we tried to add that into this, we're still going to end up with a rounding back to 1/2. Okay, so again, just keep that in mind. And I believe I told you we were doing number 9 next. So we are closer to a whole here. We're 1 part away. 5 parts over 10 giving us the half. And then we are subtracting by 1/2. I don't have to do anything with this side because it's already a benchmark fraction. And so when I do my subtraction, I'm going to get 1/2. And then number 10, we are at 3 parts over 6. That's going to be exactly 1/2. I don't even have to estimate. I'm already at the benchmark fraction. It's just using a different equivalent fraction for 1/2. 4 parts out of 5. Again, 2.5 parts would give us half of 5. So we are closer in this case to 1 than we are to 1/2. Excuse me. So we're going to round this up to 1, and that's going to give us 1.5. All right. So let's look at number 11. So I want to do a couple of the word problems, but I am going to help us go step by step So if you want to pause for each individual step, you're welcome to do that. If you want to pause and try to work out this whole thing before I explain it, or as I explain it, you're welcome to do that, okay? So we're going to have several things that we need to do in this one to make sure that we come up with the right answer. So first of all, we need to go ahead and find equivalent fractions. So we have a salad. We are going to say that we are using, okay, we want it in cups for the answer. So we have 3/4 of a cup. Now, this one is going to be exactly between 1/2 and 1. Now, you have an option here. We can go ahead and say that 3/4 is a benchmark fraction and leave it that way, or we can round up. So either one of those I would accept. In this case, if we're rounding, again, we're going to round up because we're closer to the whole number. So again, like, let's say 5 is halfway between 0 and 10. It's not really, it's actually the 6th number if we count 0, because we would go from 0 to 10. So it's slightly larger. This one is going to be larger than 1/2. But since we're the same distance from 1/2 to a whole, if we were rounding, we probably should round that up to the whole to be more accurate. So we have 1 cup of strawberries, or we can say we have 3/4 of a cup of strawberries. We're going to get a similar answer either way. And then 7/8 of a cup of peaches, which is going to round up to 1. And then 1/6 of a cup. So we're actually closer to 0 for that. So we could almost go ahead and just ignore that. Now, keep in mind, if we're going to go ahead, oh, I'm sorry, I don't have this. There we go. I forgot that I've got this part of my overlay covering that up. So if we want to go ahead and say another reason why we could just go ahead and round the 3/4 up to 1 is this is a larger amount than 0, but we're rounding it backward to 0. So to be closer to what the real estimate should be, there is an amount of blueberries going into this, not a 0 amount of blueberries. So we probably could go ahead and add that to our 3/4 and say that, yeah, we should probably go ahead and round this up to 1. So if I go ahead and do that, I'm going to go ahead and have 1 that's going to be the combination of this and saying that we're rounding up to 1. And then a 1 from here. That gives us 2 cups of salad to start with. So we can say that we have 2 cups. We are eating 11/12. So how much of that would be in relation to a whole compared to a half? We're obviously bigger than a half. So which side are we closer to? In this case, we are closer to a whole. So we could say that we ate a whole cup of salad if we're using our estimate. And so that means we would have 1 cup remaining. Let's go ahead. I want to do this part. So number 15, and then we'll talk through the homework because we're kind of at the limit of the amount of time I want to spend on this video, so you guys can spend the most amount of time actually working on things. So Aisha painted 5/6. Oh, Ellie, that name is familiar for us. Painted 5/6 of an hour in the morning and 2 1/5 hours in the afternoon. Estimate how long Aisha painted, and then we're choosing the numbers that make sense. So we're choosing our benchmark, part A and part B. So if you want to go ahead and pause and go ahead and work through that, you're welcome to. And then part C is going to be the final amount when we go ahead and add those 2 benchmarks together. Okay, so let's go ahead and figure those out. Pause the video if you need to, and then we will go ahead and talk through the answer. All right, so assuming that you did that, our 5/6 of an hour is going to be closest to 1. Again, 3 parts out of 6 would be exactly 1/2. And so since we're at 5, we're closer to our whole than we are to our half. For 2 1/5 hours, we would need 2.5 parts out of 5 to be a half hour. excuse me. So I'm actually closer to 2 hours here. And then if I add those together, that would give me 3 hours. All right, so for our homework today, you are going to notice that we are not doing all of the problems, which is fine. I would much rather you guys, especially be able to spend some time on the ones on the back. So I will talk through all of those problems. Again, we're doing the evens, so that's going to give us number 2, number 4, number 6, number 8, number 10, and number 12. So we have talked about several times that we have done this. I'm not sure how legible that is. Let me zoom in a little bit. What is an instance when you might want to find an estimate for fractions, sums, or differences than an exact answer? So we have had several word problem examples of situations where we would go ahead and probably do that. So what might be a time that we want to go ahead and find an estimate instead of the exact answer? There's a couple different ways that we could explain that. So you could go ahead, come up with what you can think of that might make sense. And at some point in time, we will talk about what the correct answer to that should be. But that will be for when we review when we get back in school. Okay. Excuse me. And then on the back, I would like you to do number 1 through 6. So again, we're working with estimates. Excuse me. So for this one, we want to estimate the distance around the lot. So we are finding a perimeter for this one. So that's an extra little wrinkle that they didn't include. So I want to make sure that you are aware of that. So I'm going to have a rectangle. I'm going to say that this is the 9/10 part. And so that also copies over to here. And then our top and bottom are both 1 1/8. So we need to go ahead and find our estimates for all 4 of those to find our estimate. So one extra little wrinkle with that to make sure that we get to the correct answer. The next one, we bought a package with this much ground meat, and then we have 2/5 of a pound left. And so we want to figure out how much we used. We're going to use benchmark fractions to help us find an estimate for that. Number 3 says we have 2 identical boxes of nails. One box weighs this amount, and we want to know the total weight in ounces of the nails. So if I have this amount and I have 2 of those, this amount in one of those boxes, and I have 2 boxes, pretty easy. So you could do 2 different things to find the correct answer for that. This one, we want to divide. We are going to do an exact answer. Our answer that we write down is how many pieces are left over. So when I do my division problem for 345 divided by 23, the answer that I'm putting is what the remainder is going to be. This is going to be my answer, okay? This is the answer, not this part, okay? Number 5, we're doing an estimate again. So we are estimating the answer. Let's pretend that we're working with money. Say what $23.63 divided up into 6 equal parts would be a reasonable estimate for that answer, okay? And then the last one, we want to figure out what our rule is. We want to figure out if we are counting up or backward. So are we adding or subtracting, and what amount are we adding or subtracting by? So that includes everything that I want to go over for today. If you have any questions, please feel free to ask in Google Classroom. Again, it's a Friday, so hopefully you have some extra time over the weekend. I will be somewhat available. So if you ask questions over the weekend, I'm probably going to be busy doing other things, but I will pop in a couple times each day on Saturday and Sunday just to make sure that if anybody has any questions, I can answer those. But I will not be on as much as I would be, say, on Friday when this video comes out. So hope you have a great weekend, and I will see you on Monday.